Hello and welcome. I am Vaibhav and our today's very first lecture of engineering drawing we'll be learning Introduction to Engineering Drawing, and also we'll be learning what do you mean by engineering drawing and what are its applications in engineering field. And lastly we'll be look after the course content which I would be covering throughout this complete lecture series on the subject. So let us begin and start with the first topic, which is what do you mean by engineering drawing or engineering graphics. So first let me give you a clarity on what do you mean by a drawing. So graphical representation of any object or information is known as a drawing. Then you will ask, sir, that what do you mean by engineering graphics? So it is a drawing of an object that contains all the technical details and informations based on engineering principles which are required for its construction is known as engineering graphics. So that's why it is also known as a universal language for engineers. So here, engineering ideas are recorded by preparing the drawings, and the execution of work is carried out based on these drawings. So for construction of this kind of drawings, we need any special kind of instruments which we are going to learn in our next lecture. So let us see this video and understand what I mean by engineering graphics. As you can see, there is one engineer who is actually planning to build a building, and for that he is now constructing and designing the drawings, and based on that drawings he will be visualizing his building like this in 3D format. And after that you can see there are a number of engineers and architects associated with that building, and they are planning where to place what, and after that they are actually going on the site and checking out the location availability, and after that they are actually start constructing their project, and before that they are actually 3D simulating the building on the computer softwares, and on these softwares they get an idea about the building strength, the cost of material, the number of items required in the building, and like so. So now after that they will be handing over this drawing to a layman or the workers who is going to build that building, and after that, as you can see, there are a number of persons involved in this activity, but they are not engineers or architects, but they are laymen or workers, and so that this is the language to communicate between either the engineers or the layman or worker, as you can see. So that's why it is the bridge between the workers, or it is a communication medium between the engineers and workers itself. So now let us move to next question, that what do you mean by artistic drawing and what is the difference between artistic drawing and engineering drawing? So we have already seen artistic drawing in our 1 till 12th standard, in which we are used to draw a drawing based on someone's creativity or the perceptions. So these are nothing but the artistic drawing. So let me give you examples on that. So let us see, if I give someone to draw a nature's drawing, then someone would draw this kind of a drawing, and some other would draw this kind of drawing. As you can see, both are the drawing looking so beautiful, marvelous, but as you can see, there is a lot more difference between the creativity of the two of the artists. So that's why known as artistic drawing, which is solely depending on your creativity. Now, in engineering application, we need not to draw this kind of artistic drawing because we need to produce certain items in actually manufacturing industry, and for that, size, shape and material and its dimension should be very well accurate. So for that, we'll be using this another kind of drawings which are nothing but our engineering drawings, and by use of this engineering drawing, if I give someone to draw this kind of drawing, then number of people with the same knowledge of engineering drawing would definitely draw this kind of drawing very precisely and accurately. And as you can see, this is another example, so which is another example with precise and accurate dimensioning. So this kind of drawings are nothing but your engineer's drawing. So as you can see the difference between these two drawings. So if I give someone to draw this kind of drawing, then they will, particularly with the knowledge of this subject, would draw almost the same drawing which I have drawn on my left hand side, and if I give someone to draw a nature's drawing, then it depends on someone's creativity, what they perceive in their mind about the nature, and they will either draw this kind of a drawing or the second kind of drawing. So that is the main difference between your artistic drawing and your engineering drawing. So let us now start with our course content. So as you know, our subject is engineering drawing, or you can say engineering graphics. So we'll be starting with first chapter, which is nothing but your engineering curves, as you can see. So let us see a brief about what are you going to learn in this chapter. So let's see. So I have made one short description for you, so you will get a basic glimpse about this chapter. So let us see. So there will be a number of curves you can see. So this is the classification of engineering curves, and there are a number of curves as you can see. So we'll be learning these curves in detail. So let us start with the first curve, which is actually not a curve, but it is derived from a conics, and we will be learning in the chapter engineering curves what do you mean by conics. Don't worry, just try to take a glimpse of this chapter. So first we will be drawing this triangle. So we will be learning this kind of object, which is nothing but a triangle, and there are a number of triangles and there are a number of ways to draw the triangle, which we are going to learn in this subject. After that, we will be learning the circle. So how to draw a circle, how to divide the circle into number of parts, we will be learning in this chapter. Now let us move to next curve, which is known as ellipse. So you have already seen the ellipse in your mathematics, as well as you have solved the examples on ellipse. But now in this subject, we will actually trying to draw ellipse. So this is the shape ellipse, as you can see. So we will be actually drawing this ellipse, as you can see, by a total of 8 methods, and there are total 8 methods to draw this same ellipse. So we will be learning in this chapter. After that, let us see next curve, which is known as parabola. So we all know, we all watch cricket, and this is the season of cricket. So we know that if someone strikes the ball from ground and it reaches to a 6 or it scores a boundary, then it follows a certain path, and this path is nothing but your parabola. So this is the shape I am talking about. We will be learning in this chapter how to draw parabola, and there are total 4 methods, and we will be learning about total 4 methods of parabola in this chapter. So now let us move ahead to the next curve, which is known as hyperbola. So we also have a total of 5 methods to draw this hyperbola. So let us take the example of hyperbola. So this kind of curve which we are going to generate in this chapter, which is nothing but your hyperbola. Now let us move to the next curve, which is nothing but your cycloid. So let us see what I mean by cycloid. So there will be one circle and there will be one straight line. So if any circle rolls over a straight line without sloping, then if we try to trace a path on any point on circumference of circle like this, then we will be having one curve that is nothing but your cycloid. So in second, you can see the curve which is here generated. It is nothing but the cycloid. So we will try to learn how to draw this curve whenever your circle is rolling over a straight line. So now let us move to our next curve, which is known as a epicycloid. So it is a different form of your cycloid, but it is known as epicycloid. In which what happens, you have one circle with a bigger radius or bigger diameter, and there is one another circle with a smaller radius which is rolling over this bigger diameter circle, and throughout on this rolling motion, it will generate one curve which is nothing but a epicycloid. So let us see what I mean by epicycloid. So this is the curve which is now generated, is nothing but your epicycloid. So now let us move to our next curve which we are going to learn in this chapter itself, which is your hypocycloid. So whenever a smaller diameter circle now rolls inside a larger diameter circle, and you will be tracing a path of point on your circumference of a circle, then it will generate one curve which is nothing but what? Hypocycloid. So this is the curve which is known as hypocycloid. So now let us move to the next curve, which is a inverted. So let's see its example. So now whenever we have one circular object and we are trying to wind a string over it or trying to unwind the string over it, and we will try to trace the end point of the string, as you can see, there will be one curve generated which is nothing but involute of a circle. If we change to a square, pentagon, hexagon, then its name changes to inverted of a square, inverted of a pentagon, inverted of a hexagon, like this. So here in case what we have done is we have just tried to wound around the string around the circle, and we are tracing the end point of the path of your string throughout its motion, and the curve generated is nothing but your inverted. Now let us move ahead and see a next curve, which is nothing but a spiral. So in spiral what happens is, so we have one circle, we have one element or inset here, and it is traveling towards the center of the circle, and while traveling it also rotates about the center of the circle, and when we try to trace the path of that insect for its dual motion, its rotational motion as well as its linear motion, we will be having this path which is nothing but your Archimedean spiral. So next curve would be helix. You can draw helix on your cylinder as well as you can draw helix on your cone, but these are not in our syllabus. We are not going to touch this helix in this particular subject. And after that you have the sine and cosine curves, which are nothing but the curves you will be learning in your electrical engineering subject. So now let us move ahead and see what is our next chapter. So next chapter is nothing but your loci of points. Loci means group of points. So loci of points means group of points. We will be having a different group of points. As we know, in our childhood days, we have a jumbo book, coloring book, in which we have number of points 1, 2, 3, 4, 5, 6, 7, 8, and we are actually connecting these points by its order, and at the end we are getting some shape as a result. So this is nothing but loci of point, but here in this case we will be dealing with some mechanism and we will be actually tracing the path of that object. So in this we have taken the IC engine mechanism. In IC engine mechanism we are having piston, guides, connecting rod and crank. We will be tracing the point on the connecting rod, as you can see, and when we try to trace it on your paper, we will be getting these points on the paper, and when we try to join these points, as we will be joining in our jumbo book, so we will be having this type of a shape, and we are getting a different kind of shape as an answer, and this is nothing but your loci of point. So it is actually used to trace out the motion of mechanism in engineering. So now let us move ahead to next chapter. So which is what? Projection of points. So chapter number 3, which is what? Projection of point. So let us understand what do you mean by projection of point. So I will be taking one quadrant system in horizontal. This is horizontal plane and this is vertical plane. These are mutually perpendicular planes. As you can see, there is one point marked there. So this point is actually certain distance height above your HP and certain distance away from your VP. So it is H height above your HP, and as you can see, it is a D height away from your VP. So now observe, we will look it from the front. We will be having one view on its vertical plane, as you can see, and after that we will try to look it or observe it from the top, and you will be having another view on its horizontal plane, as you can see. After having these views, these are three-dimensional views. We will try to rotate this horizontal plane around this connection point of your HP and VP, intersection point of HP and VP. Then we will be having these two of the planes in same vertical plane. And after drawing these views in two-dimensional open vertical plane, we will be getting our final view, which are nothing but our projection of points, which we are going to learn in the chapter projection of point. So let us observe the video and let us understand what I mean by the projection of point. So we have drawn the point which is h mm height away from your HP. I have drawn h mm height away from your HP, which is A dash, and the another point which was D distance away from your VP. So you have drawn another point downside, which is nothing but your A. So these are nothing but your projection of point. So we have taken the point in 3D actually, but we have plotted it into 2D. So this is nothing but conversion of 3D point into 2D point representation, which is nothing but your projection of point. So now let us move ahead and see next chapter. So after that we will be having another chapter, which is chapter number 4, projection of line. So in this case we will be having our element as a line. So we will be taking the same projections as we have taken in our case of point. So now your line is certain distance above your HP and certain distance away from your VP, Now observer is observing from this direction. As you can see, the front view is plotted like a straight line which is exactly the same dimension. Now we are taking the top view, looking at it from the top direction, and you can see there will be one point of view on the horizontal plane, right? So now it is very easy. Now in next step what we'll do is we'll try to convert this 3D representation into what? 2D representation. So let us revolve this plane across the horizontal dimension, and let us give the intersection line as xy. Let us plot the first line which is certain distance away from your HP or your xy. So we have plotted this line which is nothing but what? Our front view of the line which the observer had witnessed in our previous section of the video. Now we will be plotting its top view. So top view what? We have observed the point view. So now we will be drawing a point view in the top view. So now this is another case in which we have taken an inclined line. And now observer will observe, and as you can see, it is certain distance away from your HP and it is certain distance away from your VP. So after that we will be plotting this line also in two of its views. First a front view like this line, and second the top view like this line. So as you can see, these are nothing but what? The projection of lines. And after that what we will do is we will try to convert it into 2D by drawing the XY line and plotting the inclined line just above your XY line and one horizontal short distance line just below your XY line, just like this. So let us observe. This line was at theta degree with your horizontal plane. So it would be seen as theta degree, same degree with your XY line also. So as you can see. After that we just need to draw vertical lines from this, and we'll be having its top view as a short line, which is actually of a shorter length than your actual length of line. So now let us see. So this is nothing but the top. So you have two views. This is the top view of this line of two length, and that was your front view. So now let us move to our next chapter. What we are going to learn in the next chapter. So let us see chapter number 5, projection of planes. So in chapter number 5, our object is now what? Plane. As you can see, we are having this plane, and we have put the same plane into a quadrant system, and this is we have taken the plane inclined with a VP. So we have taken the front view. As you can see, it is a rectangle, and if we take the top view, then it would be an inclined line. After that what? Yes, you will be rotating this plane along your intersection point, so you will be having what? The inclined line in your horizontal plane at the theta degree. Why theta degree? Because our plane is certain degree angle with your VP. So here in case we are making angle with your XY line. After that we just need to draw a vertical line, and we need to just draw what? The front view, which is what? A rectangle. Right. So now we will be plotting a rectangle in front view in vertical plane. So which is nothing but your projection of plane. Very easy. So now let us move ahead to our next chapter. Next chapter. So it is a projection of solid. So after learning two-dimensional object, we will be now learning a three-dimensional object. So this is a projection of solid introduction, as you can see. So we have different kinds of solids. So we will be learning this kind of solids: tetrahedron, cube, prism, pyramid. So let us observe what we mean by tetrahedron. So this is your prism, or it is also known as a cube. So these are the different kinds of prisms available to you: triangular, square, pentagon, hexagon. Now this is your pyramid. So pyramid has its apex at the top, as you can see by red dot. It is indicated by red dot. These are the different kinds of pyramids available to us. We will be taking any one of the prism in this case with the 120 height and 50 as a base length. We will be taking same presentation. So we will be taking its top view from the top direction. We will be taking its front view from the front direction. And when we try to use the previous methods, what we have used in our projection of planes, will be having the same answer, and it will give us a projection of solids. Let us observe this by this video. We have drawn this pentagon. After drawing this pentagon, by looking in the top view, we will be plotting from each of the lines, each of the corners of your pentagon, the vertical line, and from that vertical line into your vertical plane, we will be actually getting a front view in your vertical plane. So now, if we try to observe the pentagon prism from the front direction, it is nothing but your rectangular shape into your front direction. So this is nothing but a rectangular, shape in the front view of that pentagonal prism. So now these are the views which we are going to learn how to draw these views in the chapter Projection of Solids. So now let's move ahead and see the introduction for next chapters. So now we'll start with the chapter number 7. So let us see chapter number 7, section of solids. We have just seen how to draw solids and how to draw the projection of solids. So now we'll be trying to draw the same projection of the solids like this. And after that we'll try to cut this solid by a section plane, as you can see. This is a section plane. After cutting, what are the answers we are getting in each of the views? And nothing but our section of solids. So we'll be having a sectional view in the side view as well as in the front view as well. We can see this parabola shape with hatching. It is nothing but your cut section, and we can also observe here in the top view. You can see there is one cut circle drawn in the top view. So which are the different views in the section of solids? Now let us move ahead and see the next chapter, which is a development of solids. So we'll actually try to develop a solid, means we'll try to open up the solid and try to see how to construct actually this solid in the practice. So let us understand, if we try to make one box and we are a manufacturer of box or packing industries and we need to construct this box. So we'll try to open this box and we'll try to see how many rectangles it has. And we try to observe the dimension of each of the rectangle, and then we try to produce this box, and this is nothing but known as a development. Means you are developing a complete surface of any solid. It is nothing but what? Your development of surface. So now observer is observing which we need to prepare. Now after that you need two dimensions. First the dimension of square, as you can see, and second the dimension of rectangle. After having these dimensions, you need to just plot the view what you need to prepare. So I have opened up this total square box, and after that I have calculated total number of rectangles 1, 2, 3, 4 and total number of squares 1 and 2. And after that I need to plot the same layout on my metal sheet, and after getting this metal sheet done, I need to just fold my metal sheet across these marks 1, 2, 3, 4, and what I will get is nothing but my box at the end. So that is it. So in this chapter we will be learning this kind of thing, which is actual practical thing. So when we need to construct our object in reality in manufacturing industry, then we need this kind of a thing. So now let us move ahead and let us see the next chapter. So which is nothing but a very interesting chapter, orthographic projections. So for this chapter actually we are learning all of these previous chapters. So orthographic means we are actually converting this three-dimensional object into two-dimensional understandable views. So in which you can see many times you purchase a new mobile phone, right? And you have seen there are three views drawn over your packet. And these are nothing but what? It's front view, top view and side view. So we are actually plotting across this XY line, front view, top view and side view of this object like this by putting at particular locations. And this is nothing but conversion of any three-dimensional object into clearly understandable two-dimensional drawing, which are nothing but known as your orthographic drawings. So now we will be taking its views in particular locations. So we have a total of here different views, as you can see. When I am looking from this direction, I will be having this view and I will be putting this view. So this is a representation of what we are going to do in this chapter. Now after that we will be having another more interesting chapter, and which is your isometric projection. So in this chapter we are actually going to draw a three-dimensional object in reality. It's so much fascinating, right? You will be learning how to draw three-dimensional object in real. So for this purpose we are learning actually this subject. So now we will be generating three-dimensional view from the object. So let us take one example. So in which I have this hexagon and I will need to construct this hexagonal prism from this image. So what I will do is I will draw a hexagon first, and then after I will try to draw a vertical line, and I will construct this object, which is nothing but what? Hexagonal prism. So we will be learning a number of objects which are more complex in this object, but this is just the example what we are just now learning. So what we will be learning in this chapter? So we will be actually converting the two-dimensional object which we have learned in our previous sections into our 3D object itself. So let's move to our next chapter, which is nothing but AutoCAD. So nowadays it is era of the software. So we'll be actually learning 3D softwares in which we are actually generating the objects. So let us see. I have this object on my left hand side. I would be actually generated and constructing this object in reality. So what I will do is, I will just draw by this line command this particular object. So let us observe. We'll be actually learning this chapter in detail, so don't worry, I will teach you how to draw this object in our subsequent lectures, but this is just understanding purpose that what you will be learning in this chapter. So now, let us move to our next chapter, which is a full and final chapter, which is dimensioning in engineering drawing. So how to give dimensioning in engineering drawing. So let us see what are the dimensions types and how we are going to give the dimensioning in this. So let us understand now dimensioning in drawing. So this is your horizontal dimensioning, this is vertical dimensioning, this is your chain dimensioning, these are your parallel dimensioning, these are your dimension to the circles, these are dimension to your circular arcs, and these are your dimension to angles. There are a number of methods to give dimension to various kind of objects, and that we are going to actually learn throughout in this chapter. So this was the course content overview in which you have seen total 12 chapters which we are covering in this total complete series of engineering graphics. So stay tuned for that. Now the final thing, without knowing the application of this subject, we can't proceed further, right? So let us see which are the application of this subject, and it is applicable to each of the branch, whether it is computer, IT, automobile, any of the branch. As you can see, it is very much important in mechanical as well as automobile for designing purposes. So it can be a useful tool for preparing a car design or designing based on the softwares you can prepare by this particular knowledge of your engineering drawing as a subject. It needs lots of practice, like you need to understand CAD softwares like AutoCAD and many more softwares you need to understand. Now as you can see, these are the engineers, these are nothing but your civil engineers or architects or interior designers. So you need a basic knowledge of engineering drawing and some advanced concept of your civil engineering practices to master in construction of buildings or preparing designs and layout of anything you want. As you can see, these are nothing but robots, right? So this is the modern era in which we are dealing with robotics, electronics and communication. So it is very much important in the branches of robotics, electronics and communication, where you can actually design this hand movement and gesture augmented reality concepts that you can design by the help of basic knowledge of engineering graphics and design. So which we are going to learn in this lecture series. Just observe the application of this engineering drawing. So now let us see finally the computer engineering. So in computer engineering you have a networking, you have a 3D interfacing, you need to prepare any security softwares. You can even use it for face recognition or in your video calling softwares as well. So these are the application of this engineering graphics. You can also use these in computer graphics to create graphics, and it is very much helpful for you to design your softwares based on this latest platforms like augmented reality. Then 3D interfacing, you can use this subject. As you can see, so there are a lot of application of this subject, and without knowing this, motor learn this subject, right? So that's why I'm showing you this clip, that you get the idea that in every field of engineering graphic is so much important. So now let us move ahead and come to a last part, the learning outwards. What we are going to actually learn by this course. So you will learn how the industry communicates within by use of technical information. So you will be learning different concepts like visualization, that means how to control the visual informations. Second, the graphical theory, that means your projections and graphical theories that you'll be learning in projection of point or projection of solid, projection of planes. Then standards, we'll be using certain standards which are actually acceptable widely in any country you go. So you will be learning the standards which we are using this particular subject. The conventions, commonly accepted practices that are to be followed while drawing any particular object. So these are the conventions we are going to learn. The tools, obviously we'll be learning and understanding various kind of spatial engineering tools which we are going to use in throughout this subject. And finally, without knowing application of any subject, it is of no use. So we will be learning the application of this subject as and when we move ahead. So that is all from my side. If you have enjoyed my lecture and teaching style, do not forget to like, share and subscribe to my channel. If you have any queries, any doubts, feel free and comment down below. Keep learning, stay connected. Bye bye.